All right, we're down to 500 grams on the wood-on-wood case. So I'm going to start pulling after I press collect and make sure everything's zeroed. Not quite zeroed, so I'm going to stop it and zero it again. And then press collect. Much better. Okay, so here goes. Alright, there's my peak right here. Press stop. There's my peak. And looks like my peak at 500 grams is 1.33 newtons right here. 1.33 newtons. And I think I got it to accelerate a little bit, which isn't what I meant to do, because that means I'm pulling it with more force than needed. So I'm going to go with right around there for the kinetic friction. And that's, again, there's uncertainty here. But I'll go with, it's very close to about 1 newton. So I'll stick with about 1 newton for that. All right. Now I'm going to go down to 400 newtons. I'm sorry, 400 grams. Here goes. I'm going to zero it again. Just think, you don't have to be doing this lab. You get to watch me doing it. So it's going to go a little bit faster than it would have taken with you. You just have to watch me doing it and know what you would have done. So that's the best bet, is think you would have been doing something like this. All right, here goes. I'm going to give it a pull. It gets harder and harder to do it as the weight gets smaller. Harder to actually see how much friction it takes. So I'm looking for that little peak right there for the static friction. And I am seeing about 0.84 newtons. Oh, I'm sorry, I take it back. 0.95 newtons. Okay, and then for the kinetic part, this is a little rough. Boy, I'll go with about 0.8 newtons for kinetic. That's at 400 grams. Going down to 300 grams. All right, make sure everything looks zeroed. I'll just zero it every time, if I remember. And if I don't, I'll see it not be zeroed and I'll do it. All right, here goes. All right, there's the peak right there. That peak happened at about 0.9 newtons. Okay, and then the kinetic friction part, somewhere around here. I'll go with about, what I could do here is I can actually average it over that region. The average says about 0.74 newtons. Down to 200 grams. Getting there. Zero this. Here it goes. Okay, 200 grams. Give it a pull. As we see a peak, it's getting smaller and smaller as you'd expect, because it takes less and less force to overcome the force due to static friction as the normal force goes down. And it looks like here we have 0.75 newtons for the kinetic friction. And for static friction, for the static friction, 0.75 newtons to get it moving. That's the static friction. Kinetic, I'll take an average over that region there. And kinetic friction, it looks like about 0.44 newtons. For kinetic friction, 200 grams. Getting down to the bottom here, 100 grams. I forgot to zero it. Some of you probably remembered. Here we go, 0. Collect. It's getting down there. Just look at that thing. It's so small. Can do this. Expand it a little bit. And what I'm seeing here is the peak is getting close to the resolution of the instrument there. About 0.45 newtons for the static, and for the kinetic I'm at about 0.29 newtons for kinetic at 100 grams. Here we go. It's the hardest one to measure of all. 0 grams wood on wood. Now, it's not 0 grams. Remember, it's the weight of this. It constitutes the normal force. So it's 54.3 grams. So you need to add that to all the other masses to actually determine the normal force. So this is the smallest I'll get, 54.3 grams. Convert that to normal force by multiplying it by g after you convert it to kilograms. So 0.0543 kilograms times 9.8 meters per second squared, or 10 meters per second squared. I guess I'd go with 9.8, but whatever you do is going to be close. Okay, here goes. I got to zero it. Okay, let's see if I can see anything here. Can't even feel that peak, but oh my gosh, look at that tiny little peak right there. Wow, almost nothing. Let's see what it peaks out at. Looks like it made it to, oh my gosh, 0.07. Oh no, I take it back. 0.1 newtons right here. Looks like it's at 0.1 newtons. 0.1 newtons. I'll just round it there. And then for kinetic, talk about small numbers here. Kinetic friction, I'll do an average. It's like 0.05 newtons. I'll go with that for kinetic. All right, we did half of it now. Now I'm going to go to the sandpaper side. Maybe I'll work my way up. I'll work my way down on the other side, I'll work my way up on this side, save time. All right, so sandpaper side, 54.3 grams. Convert that to what the normal force would be. Zero it first. What's nice is with sandpaper we should see bigger peaks because there's going to be more friction. Here goes. Barely see a peak at all there, but stop it. But it's certainly bigger than it was. All right, let's see what we got here for the peak. It's like about 0.2 newtons. I'll go with that. That's for static. For kinetic, take that average. And it looks like I have 0.13 newtons for kinetic friction. 100 grams. Working our way up now. Zero it. Okay, there's the peak. Whoop. There. Peak at 100 grams for sandpaper on wood, 0.75 newtons. And the kinetic friction, looks like I got 0.53 newtons. 200. Zero it. Collect. There's the peak for the static right there. What is it? Looks like about 1.23 newtons, 1.2 newtons if you round it to the nearest tenth. Kinetic, a little hard to see, it varies a bit. I'll take the average. Looks like about 1.18 newtons for the kinetic at 200 grams. 300 grams. It's working our way up. Zero this. Here it goes. There's the peak. $300 grams sandpaper on wood. Looks like my peak is representing the static friction, 1.75 newtons. Kinetic friction, .44 newtons. 400 grams. Okay, there's the peak right there. 400 grams, the peak seems to happen at about 2.6 newtons, or 2.59 newtons. Kinetic friction, about 1.99 newtons, very close to 2 newtons for kinetic friction. 500 grams, we're getting there. Okay, that was just me moving it around. Okay, there's my zero, here goes. Yeah, let me try that again. Okay. Stop. There's my peak. I get 2.98 newtons for static, and for kinetic, I get 2.65 newtons kinetic. 600 grams. Here goes. All right. For static, my peak is 3.72 newtons. For kinetic, looks like I am at 3.35 newtons. 700 grams. It's getting harder and harder to pull this, as you might expect. $700 grams. All right, there's my peak. That's kind of weak. I'm gonna do it one more time. Zero it again. It goes. 700 grams. Okay, there's the peak. And it looks like the peak is 4.38 newtons for static, and for kinetic, I'm waiting. Come on, really? I'm waiting? There we go. Try it again. I'll have to press stop. Okay, for kinetic, I'll go with 3.50 newtons for kinetic. 800 grams. Getting so close to the end here. You can just taste it. All right. Here we go. Static friction, 800 grams, sandpaper on wood. There's a weird vibration. I'm going to do that one again. Okay, here it goes. Getting harder and harder. I thought it would get easier and easier as it got heavier. Try one more time. Maybe what I'll do is I'll actually pause this. Be right back. Okay, I taped down the weights. This is odd. Okay, I restarted Logger Pro. It was doing something weird. So when things go weird, restart the application sometimes. Okay, here goes. 800. Still doing that funny vibration thing, but here's what I'm going to do. I'm going to take, when it vibrates, it actually seems to alternate between stopping and starting, so I keep getting kind of a static friction. But I'm going to take that first peak to be my static friction peak. And I'll see where it maxes out. Maxes out at about 4.61 newtons. Kinetic friction at 800 grams. take that. I'll go with statistics there. 4.12 newtons for the kinetic friction. 900. Here it goes. There's the kinetic or the static peak, and at 900 grams, static peak is at about 5.04 newtons. Kinetic friction, .39 newtons. Okay. Last one. Zero. Collect. Here it goes. All right. I'll take this first peak to be static friction. That's putting it at 5.72 newtons for static. Kinetic, I'll go around here and take the statistics that, and I get about 5.07 newtons for kinetic. All right, so now you have all these data. Put the camera back up on me as best I can. So now you have all these data for static and kinetic friction for both the sandpaper on wood and wood on wood. So you can actually have 4 different graphs where on the y-axis you'll be plotting the friction force that you measured that I repeated. That was the number that I gave. And on the x-axis, that's where you'll put the normal force, which will be the total mass, including the mass of the plank, times g, which will be the same as the weight. And in this case, the weight and the normal force are equal. So the y-axis friction, x-axis normal force, for the 4 different graphs, you should see, if you look at the slope, the coefficient of static or kinetic friction for the 2 different surfaces. And it should be close to a line, and that's the second part of the lab, is coming up with that value and then answering any questions that are in the lab handout. Okay, good luck to you. If you have any comments on this, on how it could be made better or what you liked about it, that's helpful, because this is how we may be doing the rest of the labs this semester. It's a work in progress, as you can tell. It takes a lot of time. I want to make sure it's the best possible thing for you, given the situation. Okay, take care of yourselves. Bye-bye.